I'm Ashlyn.
And I'm Taylor.
And today we are highlighting the mathematical model base 10 blocks. What are base 10 blocks? They are mathematical, three-dimensional manipulatives used to teach students the concepts of addition, subtraction, place value, counting, and number sense. And older students can also use it to learn division and multiplication as well. It is best used to teach students basic arithmetic and number sense. Base 10 blocks help students by showing them physical representations of numbers. It also allows students to group numbers based on their place values and to combine them to make larger numbers. They can also assist in practicing mathematical operations by having students take away blocks to represent subtraction or add blocks to represent addition. Base 10 blocks come in units, which are ones, long rods, which represent tens, flats, which represent hundreds, and cubes, which represent thousands. The CSA sequence concrete when using base 10 blocks. In a classroom, the students would use the physical base 10 blocks to practice counting, identifying place value, and solving mathematical operations. For remote learning, the students can use the following websites to practice with base 10 blocks, since they probably don't have their own sets of base 10 blocks with them at home. Cool Math for Kids, Toy Theater, and Didax all have virtual base 10 blocks for students to use. Some hands-on activities that you can do when practicing concrete learning of using base 10 blocks are that the teacher can give students a number and the students have to create it using the base 10 blocks. This can be done virtually or in person. Or the teacher can give students a certain number of blocks and have them sort them into groups based on place value. So the teacher could give the student 3 rods and 4 units, and then the student would sort them into the rods and the units, and then they would figure out what the total number would be based on having 3 tens and 4 ones. And the CSA sequence with SemiConcrete learning using base 10 blocks, the students can draw their own base 10 blocks to represent a number or group of numbers specified by the teacher. So here you transition from using the concrete manipulatives to having the students draw out their own visual representation of the numbers. For example, the teacher could tell students to draw base 10 blocks that represent 2 tens, so 2 rods, and 3 ones, so 3 units. To represent addition, the students can draw more blocks and shade them in to differentiate them from the original drawings. Or to represent subtraction, the students can draw red X's over the blocks being taken away.
Thank you, Ashlyn, for sharing the introduction. Now we will be talking about the third CSA sequence known as abstract. For this, it focuses on students are now writing out the equations and numbers on their paper. The students are no longer using only the manipulatives or the drawings and are now writing the representation for each problem. After the students write out each number in the problem, they will solve the problem. For remote learning, this can be used by using Padlet or Jamboard, where the students will be able to write out their problems. An example would be students writing 5 minus 2 equals 3, 1 plus 6 equals 7, or 4 times 5 equals 20. We have included a picture to the right-hand side that physically shows the concrete. Here you have the base 10 blocks, a representational where they're adding squares as a representation, and the abstract, they are writing 4 plus 5 equals 9. For the class activity, we will be focusing on the concrete CSA. The students will be focusing on the question 10 plus 4 equals, and that is what we're going to be aiming towards solving. We will be clicking this link that will bring you to this, and you will be choosing whichever color you like to represent the 10 and to represent the 4. And then you will be adding them all together to see what the answer is. Afterwards, you will be put into small groups, and you will be sent into breakout rooms to discuss your answers. Thank you.
Thank you.